So this podcast is Entropy. And the arrow of time. So what is the arrow of time? Well, if we look at a couple of processes, we can see that the first law doesn't really tell us what's going to happen. It describes how it happens, but not what's going to happen. So for instance, if I have a hot block at some temperature T high and a cold block at some temperature T cold, we know what's going to happen. We know heat is going to be transferred from hot to cold. And the first law tells us that energy is conserved. If we lose 10 joules from the hot block, we'll gain 10 joules on the cold block. But the first law doesn't tell us why it doesn't go the other way. Why is it that if we saw heat being transferred from here over here, we'd say, no, it looks like this film strip's running backwards. It looks like there's an arrow of time that goes with the heat being transferred in that direction. Another example would be a situation, actually, if we want to do this a little better, we could say the arrow of time is like this. We have the two blocks, and now we have a situation where they're both warm. So the arrow of time is moving in that direction. So let's look at a second example. Let's imagine that we have a ball. Here's the ball, and the ball is going to bounce. And so it had a bunch of potential energy, then it had kinetic, then it had potential when it was squished out at the bottom. There's a lot of kinetic, now potential when it's squished out at the bottom, now kinetic, now potential and height. And we know what's going to happen. The ball is going to bounce along, and then it's going to come to rest. Okay. We know that this is what happens. And now we might ask, where did the energy of the ball go? Well, at the start, we'd say the ball was high, so it had potential energy. And right towards the bottom, maybe right here, we'd say that it had kinetic. Now down here, the ball doesn't have any potential or kinetic energy, but we know energy is not lost, right? We know that if we measure that very accurately, the temperature of the ball would be higher, and so we have internal energy is where the energy is being stored now. Great. So we didn't lose any energy. That's all the first law talks about, though, is the energy is conserved. What it doesn't say is why this process can't go backward. Why can't we take a hot ball and rest it on the countertop and just wait, and it'll start bouncing, getting higher? Well, I guarantee that if you rest the ball on a countertop and it's hot and you wait for it to cool off and start bouncing, you'll be waiting a long time. So it seems like time only goes in one direction. So this is something that we call the arrow of time.